You'll notice I've labelled it trig integrals 1, because in extension 2 we're going to look at trig integrals in a lot more detail. So they'll be like trig integrals 2. So trig integrals 1, we have our basic integrals that we know. So integrate sine, we get minus cos. Integrate cos, we get sine. Integrate sec squared, we get tan. So they were the first 3. Tan, and if you ever forget tan, you can set it up as sine on cos. You basically get derivative on function. You get minus the log of cos, or if you prefer to have a positive, that would be the log of sec. Is that negative, bring in power -1, reciprocal of cos is sec. Okay. Sec tan, I always throw it in there. It was probably not seen as much as it used to be. It used to be used a lot when conics was in extension 2, but that's a topic they took out of extension 2. But I always throw it in there anyway. So the integral of sec tan is sec. The complementary ratio idea. If you want to integrate a complementary trig ratio, then the answer will be minus the complement of the answer. Integral of cos was sine x. Integral of cosec squared becomes minus cot. Integral of cot becomes the log of sine. This is what I say. Look, cos was the complement of sine. So the answer is negative the complement of the answer. Well, the answer for sine was negative cos. So the answer for this one is minus the complement. Becomes positive, becomes sine. The integral for sec squared was tan. So the integral of cosec squared is minus the complement of tan, which is cot. The integral of tan, we said, was minus the log of cos. So the integral of cot becomes plus, change the sign, the log of the complement, well, the complement of cos is sine. And the sec tan went to sec. These are both the complement there, so you got cosec cot must go to minus the complement of the answer, minus cosec. So you'll always see that relationship, and the reason why you see that relationship is because they're complementary ratios, which means you could always change the angle to be pi on 2 minus x and change it to the other ratio. Then when you differentiate, because you're now differentiating minus x instead of x, you get the negative out the front. So that's why it produces always the negative of the answer. Integral of tan, log of sec, this is what I was saying. So cot is the complement of tan, so the answer is minus the complement of the sec is cosec. So that's how we get the answer. Then we started using our double angle results, which allowed us to do squares of trig functions. Sine squared we can rewrite as a half of 1 minus cos 2x. Integrate that, there it is, x on 2 minus a quarter sine 2x. Cos squared we can rewrite half of 1 plus cos 2x. You get x on 2 plus a quarter sine 2x. Oh, if you wanted to, of course, sine 2x you could then change to be 2 sine x cos x. They're the same answer. I guess it all depends again what you're doing with the answer, whether you want to do that or not. Sec squared, well, that's one of our standard ones. That just goes to tan, and cosec squared, as we just saw, minus cot. Tan squared, that one we can do with our identity. That becomes sec squared minus 1. Then the sec squared goes to tan, the 1 goes to minus x, which means cot squared. Now this one's important, have a look. The x, you'll notice the sign doesn't change. It's the trig ratio where the sign changes. So this goes to minus cot minus x for that complementary idea. Okay, let's do some. Cos squared of 3x. Well, cos squared I could rewrite half of 1 plus, double the angle, 6x, and then we integrate. Sin x cos 2x. Gonna have to play around with this one. Products to sum. It becomes sine 3x plus sine of negative x. If I know me, I didn't leave it as sine negative x. I would have used the fact that it's an odd function, did I? Yeah, I did. Sine is an odd function, so it becomes minus sine x. And I've now got two things I can quite easily integrate, and I have my answer. Sine x cos cubed. Whoa, what's causing me the problem? The problem is the cos. So this is one where I want to set it up to be the derivative times the function to some power. Well, the function is cos x. The derivative of cos x is minus sine x. So let's set it up so it looks like what I want. Minus sine x cos cubed x, and I've got minus out the front. It's now in that form of derivative times the function of some power, so I can just add 1 to the power over the power. It becomes cos 4x on 4, and you might be thinking, hang on, where'd the negative go? But have a look what I did with the limits. That's the other trick that I used here. I can get rid of that negative by swapping the limits around. Now, you don't have to. You could leave it as negative, have the limits the other way around. Substitute in, we get our answer, 3 on 16. So 12c, we'll look at some trig integrals.